Yes, student, the concept common ion effect is one of the very important content which is also applicable during the practical of detection of cations and acidic and basic radicals. Therefore, you have to give proper concentration. It is because not only in the theory exam the question is asked, but in the practical exam during the viva, external frequently asked this question. Getting? Student, like here the term is given common ion. Student, you know that weak electrolyte, okay, say weak acid or weak bases, they already ionizes very feebly or weakly. Getting? But sometime during the salt analysis it happens that we require even very less amount of ions of particular reagent. Here we are using the term and the content what? Common ion effect. That is what? The weak acid or weak base, although they ionize very weakly, however we need even very less quantity of their ions, that is their ionization. So how to check the ionization, that is how to prevent further the ionization of weak acid or weak base or simply weak electrolyte. Getting? So in the common ion effect, to suppress okay, of ionization of weak acid, I am using the term besides of it what? Weak electrolyte by adding some strong electrolyte, one strong electrolyte, okay, containing at least one common ion. Okay, this is known as common ion effect. Common ion effect. Like I am symbolic presenting you. Suppose Ha is one of the weak acid. So already its aqueous solution ionized very feebly, that is very less quantity of H and H cation and A anion produces. But if we add any one strong electrolyte containing, like suppose there is what? H cation is present, isn't it? So that strong electrolyte must contain at least one common ion. Are you getting? Like here now Ha is there, so we can add Ab or we can add Ac. Getting? If I am adding Ab, now this is what? Strong electrolyte, so it will give what? A anion plus B cation, and Ac will give again what? A anion plus C cation. Now the concentration of A anion, okay, in the product side is getting increases. According to Le Chatelier's principle, this increased concentration of A anion will combine with H cation to again form Ha undissociated Ha molecule. That is already its ionization is less. Ionization is lesser. Okay, but if we add some strong electrolyte, then due to production of common ion present in them will further reduces its ionization, thus very less quantity of H cation available for the reaction. Like here we can take the example of acetic acid. Acetic acid. Now the aqueous acetic acid ionizes and forms acetate ion plus H cation, which is already in what? Lesser quantity. Lesser quantity. Okay. But if we add CH3COONA, what is it? It is now strong electrolyte. Strong electrolyte. While it was what earlier? Weak electrolyte. Weak electrolyte. Now being it is strong electrolyte, it will produce large number of acetate ion plus what? Na cation. Now student, you know, according to Le-Chatelier principle, if in the product side one of the ionic concentration is increases, then the increased concentration will react with H cation, and therefore the reaction will shift to backward direction. That is what? That is its ionization will further decrease. And being its ionization will decrease, this concept is known as common ion effect, because very less quantity of H cation will be available there. Like student, its application is also there, and this application is very important. Okay. During detection of second group basic radical. Second group basic radical. Okay. H2S reagent is used. Reagent is used. Okay. Which is weak acid. Which is what? Weak acid. Okay. And it ionizes as H2S. On ionization forms 2 H cation and H2 anion. Okay. But to form precipitate, okay, S2 anion require in very less quantity, require in even lesser quantity, okay, because its solubility, because the solubility product of second group ions are less, okay, quantity. So to suppress the ionization of H2S, small amount of HCl is added with it. Now student, you know that HCl is what? It is a strong electrolyte. So its aqueous solution gives H cation plus Cl anion. Now in the product side, the quantity of H cation increases, like here H cation and here what? H cation. So the increased quantity of H cation again reacts with